ascending.
Now 20 seconds in. R180 propellant utilization system has gone to closed loop control system response. Good. Now passing 30 seconds into flight. Vehicles completing the pitch over maneuver. Body responses continue to look good. Engine operating parameters continue to look good. SRB chamber pressure within expected ranges. Now coming up on 58 seconds into flight. Body rates continue to look good throughout this stage. Now 3 minutes remaining in the booster phase of flight. Now passing 1 minute, 30 seconds into flight. SRB chamber pressure tailing off now as SRBs are burning out. And we have SRB burnout. RD-180 throttling down slightly as expected. Engine response looks good. Now passing 1 minute, 50 seconds into flight. Body rates continue to look good throughout boost phase. RD-180 engine operating parameters continue to look good. Now 2 minutes into flight, we have good indication of jettison of the SRB. The Atlas V now weighs 1/2 of its liftoff weight. And vehicle's gone to closed loop steering. Body rates look good. Two minutes remaining in the booster phase of flight. Atlas V is now 38 miles in altitude, 35 miles downrange distance, traveling at 4,200 miles per hour. Now 2 minutes, 40 seconds into flight. RD-180 pump speeds and injector pressures continue to look good. Body rates continuing to look good throughout boost phase. Now passing 3 minutes into flight. And Centaur reaction control system is now pressurizing the flight levels. RD-180 now throttling down to maintain a constant 2.5 G acceleration limit. Engine response looks good as it's maintaining that 2.5 G acceleration limit. Now 1 minute remaining until BECO. And standing by for payload fairing jettison. And we have good indication of payload fairing jettison. And we have CFLR jettison. Now 3 minutes, 50 seconds into flight. Body rates continuing to look good. And RD-180 now throttling to maintain a constant 4.6 G acceleration limit. And we've begun boost phase chill down. And standing by for booster engine cutoff shortly. And we have BECO, booster engine cutoff, standing by for stage 7. We have good indication of Atlas Centaur separation. We have pre-start on the RL-10. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good. And this first burn of today's mission will last approximately 8.5 minutes. Now passing 5 minutes into flight. Centaur's gone to closed loop steering. Body rates continue to look good. And the RCS system has begun initial thruster firings for thermal conditioning as expected. Centaur is now 140 miles in altitude, 420 miles downrange distance travel.
This is Atlas Mission Control at T plus 5 minutes and 25 seconds. We just heard flight commentator Patrick Moore confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in approximately 8 minutes. Earlier this week, Patrick Moore shared a little insight about his role as flight commentator and the vital information he relays to the launch team post-liftoff. Let's take a look.
Hi, my name is Patrick Moore. I'm a systems engineer in the Chief Engineer's Office at ULA, and I'm also your flight commentator for USSF-8. So my job as flight commentator is I'm taking a look at the screens here. I have some plots and schematics, and I'm also looking at the video on the wall. And so what I do is, as we're lifting off, I'm looking at the video, confirming that what I'm seeing on the screens are consistent. And then I'll start taking a look at the data in the plots and the schematics. And so my job as flight commentator is I'm looking at the data that I see here, and then I'm talking about it over the broadcast and on the net. And so the folks at ULA will be listening to my commentary. And so we have engineers that cover all different disciplines: avionics, structures, thermal, and many others. And so what they're doing when they hear commentary is it just kind of helps give folks perspective of where we are in the launch and what's coming up. So an engineer will be looking at their specific system and all the different things that are going on with what's specific to their hardware in flight. And so my commentary helps tell them, okay, something's coming up that I might need, or that I should expect to see a change in my data in a certain way. And then obviously my commentary goes out to folks around the world watching the ULA broadcast. And so my job as flight commentator for them is to help provide some perspective of what they might be seeing on the broadcast and on the video to just help kind of pull everything together. So one thing that's interesting about flight commentary, when we have the rocket in flight, we're getting thousands of different measurements that we can select from, and they cover all different things from top to bottom of the rocket. So our job as flight commentators is we want to pick maybe 40 or 50 different measurements that give us an indication of how the vehicle is doing in general. We look at that in the plots here and in the schematics, and that really gives us more of a general feel that the rocket's doing well in flight. And then it's the job of the rest of the engineers throughout Denver that they're looking at much more specific measurements, like a temperature on an avionics box or a pump speed in the engine or things like that. And so we may not look at those, but we want to look at maybe general indicators that tell us that the whole system is doing well. So I certainly get a little bit nervous before every launch. I've been doing this flight commentary for 4 years and about 12 launches, and I think I get nervous every time. I thought it would go away, but it doesn't. So I get really excited. There's a lot of adrenaline going, especially in the last couple of minutes before launch. And I think one of the challenges of being a flight commentator is you have to, you know, kind of live within that adrenaline, but also talk yourself down a little bit and stay focused on reading the data and talking over the net. And sometimes it's a little bit of a challenge, but it's always exciting. So for USSF-8, there's no difference in how I feel leading up to this launch. I'm really excited and can't wait.
Approximately 4 minutes now remaining in the burn.
We are about 4 minutes away from MECO 1. While we wait, this year, ULA's interim cryogenic propulsion stage will launch atop NASA's SLS rocket. ICPS will be carrying the Orion capsule to orbit. Let's hear the latest updates on this program from ICPS Avionics lead engineer, Joven D. Herrera.
Hi, my name is Joven D. Herrera. I'm the avionics lead on ULA's Artemis program. Our whole team is excited to be part of America's journey back to the moon. ULA is working collaboratively with the Boeing company to supply the interim cryogenic propulsive stage, ICPS, for the Artemis 1, 2, and 3 missions. The ICPS is a modified Delta IV cryogenic second stage that is the second stage of the SLS rocket. This week, we are conducting program-specific engineering testing. This is a collaborative test with the whole SLS team to ensure all of the hardware powers on nominal and the vent and pressure systems respond appropriately. ULA is managing the ICTS power during this test. The Tiger team is a dedicated team on console that will support NASA's launch team. We work closely and collaboratively to monitor all aspects of ICTS during pre-launch and in flight. We are so excited to be playing our role and returning back to the moon.
Now passing 11 minutes into flight, just over 2 minutes now remaining in the burn. Centaur systems all continue to perform nominally throughout the burn. Seeing good stable pressures on the RL-10. Body rates remain stable. Thruster activity continuing as expected.
This is Atlas Mission Control at T plus 11 minutes and 54 seconds. We are now approaching main engine cutoff 1. Let's listen in.
Passing 12 minutes into flight, approximately 1 minute now remaining until MECO. Centaur is now 200 miles in altitude, 1,960 miles downrange distance, traveling at 16,350 miles per hour. Thirty seconds now remaining until engine cutoff. RL-10 operating parameters continue to look nominal. Body rates remain stable, now about 13 seconds until engine cutoff. PU's gone to open loop in preparation for MECO. Standing by for cutoff. And we have MECO.
This is Atlas Mission Control at T plus 13 minutes and 20 seconds. Patrick Moore just reported the successful completion of the first of 3 Centaur engine burns. Centaur is now coasting over the Atlantic, but we still have a long way to go. The 2 US SF-8 satellites are scheduled to separate from Centaur into a near geosynchronous orbit in about 6.5 hours. Before we leave you, here is US SF-8 Mission Director Colonel Aaron Goulden discussing the criticality and diversity of our space partnerships and how they contribute to mission success.
It's truly an honor and a privilege to have served as your mission director and to be part of this amazing team that's delivering our space situational awareness payloads to orbit. Our space capabilities, they touch every facet of our lives. They advance our understanding of the universe. They allow us to see our world with greater clarity, more accurate navigation, stronger global commerce and communications. They enable precision farming and agriculture. And overall, they just allow us to operate with greater assurances. So your Space Force Guardians, we protect those assurances and our freedom of action in space. We're pathfinding innovative and resilient new space capabilities, but we don't do that alone. We work across strong allied partnerships, sister services, and our industry teammates to do so. So you remember when you were young and you looked up at the vastness of the stars in the sky? It was inspirational. The idea that space, it represented the unknown, that opportunity to dream and feel as though we could be part of something so much bigger than ourselves. It inspired our imaginations. But those of us who are dreamers, we're not just engineers and scientists. We're extremely skilled craftsmen, trade technicians, and others that build our rockets and our spacecraft. We're journalists, business and financial specialists, doctors, lawyers, contracts experts, logisticians, program managers. We are a mix of diversity of thought, perspectives, and expertise that all come together within the space enterprise. And today, it's truly my colleagues that keep me inspired. They're uniquely talented and a truly committed industry, government, and civil partnerships that we've built a foundation of teamwork and trust that is vital for us to stay competitive across the domain and continue to champion the safe and responsible use of space. Our bold and ambitious national space missions continue to show us that our future is truly unbounded. We're creators, we're innovators, we're leaders. And it's such an exciting time to be part of this evolving industry. There's an incredible amount of opportunities across so many disciplines to be a part of it. I am so proud of each and every member of our USSF-8 team. But I said there's so much more we can do. I challenge us all to keep dreaming, keep innovating together, and never let anyone turn our stars into a ceiling.
I'd like to thank Patrick Moore for his participation in today's show, as well as Brian Sizek from Space Launch Delta 45 Weather. You can stay updated on today's long ascent with ULA's live blog at ulalaunch.com or join the conversation on Twitter and Facebook. I'm Caroline Kirk. Thanks for joining us today. Before we leave, we'll take another look at liftoff, which occurred at 2 p.m. Eastern Time.
USSF-8. ECDS reduced for launch.
10, 9, 8, 7, 6, 5, 4, 3. We have ignition and liftoff of the United Launch Atlas V rocket carrying SF-8 for the United States Space Force.
Now 10 seconds in flight, vehicles begun the pitch over maneuver. Body response look good.
You're now hearing the voice of Patrick Moore providing launch vehicle ascent data.
Now 20 seconds in. RD-180 propellant utilization system has gone to closed loop control system response looks good. Now passing 30 seconds into flight.